Number 6 is a very similar problem. So we have a sailboat that leaves a pier heading due west at 8 knots. And then after 15 minutes, the sailboat tacks. That means it turns. And it changes course to north 16 degrees west at 10 knots. And we want to find the sailboat's distance and bearing from the pier after 12 minutes. So we're going to start by drawing this again. We'll start with our coordinate plane. And the pier is going to be at the origin. Oh, let me get a pencil. There we go. Okay, so the first thing that we're going to do is head due west at 8 knots. So right there. Now, we don't know how far that is. So to do that, remember we have distance equals rate times time. Its rate is 8 knots. And it's on that course for 15 minutes. Now, 15 minutes is a quarter of an hour. So it has gone 2 nautical miles there. I think that's right. Yep, 2. Okay, once it hits that point, it's going to change course. And it's going to go from the north 16 degrees to the west. So just like that. Okay, and let me draw that in there. So from that north, that's where our 16-degree angle is. All right, now that distance, we'll just do distance equals rate times time again. I'll just erase that so I have room. It's also changed speed. So now we're at 10 knots, and we're going to be on that course for 12 minutes. Well, 12 minutes is a fifth of an hour. So this distance is also going to be 2. So that's 2 right here. And we want to find from this point the sailboat's distance and bearing from the pier. So we're trying to find this. I'm going to call that Z again. That'll be fine. Z. And in order to find the rest of that, we need some right triangles. So we'll drop this side down and this side over. Just pretend it's on the line. And I'm going to call this X and Y. So, remember that was 2. Okay, so we're going to find X and Y, and then we'll use that to find Z. So we're going to do that really similar. If this thing is 16 degrees, that means this angle is 90 minus 16 degrees. So that is going to be a 74-degree angle. And then that triangle, in case you can't see it very well, I can redraw it down here. Okay, this XYZ triangle, here's what it looks like. Or X and Y triangle. Okay, so we have X, Y, this side is 2, and this is 74. Okay, so that's what that is, just popped out so you can see it a little bit better. All right, so we want to find X and Y. So I'll start with Y. We have the sine of 74 is opposite over hypotenuse. Multiply both sides by 2. And Y is 1.9. And then we'll do the same thing with X. So the cosine of 74 is adjacent over hypotenuse. Multiply both sides by 2. And X turns out to be 0.6. And then to find Z, we'll just do the Pythagorean theorem on those. And we can do 1.9 squared plus this whole side is going to be 2.6 squared equals Z squared. Okay, and when you finish that out, Z looks like it is 3.2. All right. So that is the distance. We also want to find the bearing. So remember bearing, we're going to need to find this angle. So I'll probably use a tangent again. So the tangent of theta is Y. Y was 1.9 over this whole side, which is X plus 2. So 2.6. Sounds good. We'll do the inverse tangent of that. And we get 37 degrees. Now, that is not the answer. That's this angle. Remember, we measure our bearings from the north. And so 90 minus 37 degrees is going to be 53 degrees. So our bearing is north, 53 degrees west.